Okay, polynomial equations and functions. Okay, what you're doing here is determine the end behaviors of each of your functions. Now you don't have to draw this. I'm just explaining what it means. Okay, it means if I graph that, it forms a roller coaster. Now this side is x positive infinity. That side is x negative infinity. So that roller coaster, I got to decide what it's going to do on this side as x goes out to positive infinity, and what it goes over here when x goes out to negative infinity. So the first equation, y equals negative 3x to the 5th power plus 4x to the 4th power minus 3x to the 3rd power plus 5. Now it's in proper order. Now the end behaviors are determined by the lead coefficient and the degree. So the lead is negative 3. Now since that is a negative, the graph goes down, which would mean negative infinity. Okay? And the degree is 5. So since 5 is odd, okay, then the end behaviors have to go opposite. Okay? So positive infinity. Now in this little thing I drew here, that means it'd be going down this way, and then it'd form a roller coaster, and that way it'd be going up. Okay, you don't have to graph it, but yeah. Okay, y equals 4x to the 10th power minus 5x to the 6th power plus 3x to the 3rd power minus 10. Okay, so your lead and degree. So the lead coefficient is 4, okay, and it's a positive 4, so that one's going to be positive infinity. Remember, this side is determined by the lead coefficient. This side is determined whether the degree is odd or even, okay? So the degree is a 10. Now this time it's an even degree, so they have to match, okay? So it'd be positive infinity, and then to match it, you'd have positive infinity. Okay, now this one here, y equals 9x to the 4th power minus 3x to the 3rd power plus 4x to the 2nd power minus 6x plus 7. We find our lead and our degree. Okay, so the lead coefficient is 9, positive 9, so that's a positive infinity. And the degree is a 4, okay, and that's an even, so that's a match, okay. So positive here, positive here. Okay, now in the next section, write a polynomial function for each set of zeros. Only real rational values need to be visible in the equation. That means no radicals, no i's. Well, I don't have that problem in this one. So I always start x minus 1, x minus 2, x minus, oh, it's a negative, well, it'll be plus 5. And that's good to go. Okay. No i's, no radicals. Okay, number 5, well, we have a radical and an I. Well, those come in pairs, so I also know I have a radical 2 with a negative on the outside, then a positive 3i. Okay, so that's 4 zeros you have to account for. So I make 4 parentheses. X minus, we'll make that a plus square root of 2. X minus, we'll make that a square root of 2. X minus 3i, and x plus 3i. The order doesn't really matter. Now, I said no radicals, no i's, so that means we have to find these products, okay? I'm going to end up with only 2 parentheses. Okay, now, remember, kind of the FOIL's a waste of time when you have a plus and a minus of the exact same term. So what we're going to do is just apply x times x and square root of 2 times negative square root of 2. So that's x to the 2nd. Now positive times a negative gives me a negative. Then I open a square root and take 2 times 2, that's 4. But ain't the square root of 4 2? Yeah. Now you're like, what about the I? You don't do I because the negative's outside the square root. okay? So that turns into just 2. Square root's gone, okay? So it's x to the second power, and since the 2 is negative, it's expressed as x squared minus 2. Okay, then here, x times x, and then negative 3i times positive 3i. So that's x squared, and that's going to give me negative 9i to the second. Okay, but I to the second is negative 1, so it's really negative 9 times negative 1, which is 9. Now, that's a positive 9, so we express it as x squared plus 9. Okay. Now I could make you multiply those out, but I'm not going to. Number 6, you got 6 square root of radical 3, so you'd have negative radical 3. Those come in pairs. Negative 8i, and then an assumed positive 8i. Okay, so that's 5 parentheses I need to start with. I'm not going to end up with 5, but so x minus 6, x plus the square root of 3, and then x minus the square root of 3. X minus 8i and x plus 8i. Now I got to find these two products here. Okay, the x minus 6 can just stay because it doesn't have a radical, it doesn't have an I. Okay, so x times x, and then positive square root of 3 times negative square root of 3. So that's x to the second. Positive times a negative is a negative, and I open a square root and I multiply the 3's. That would be 9. But the square root of 9 is 3. So I will be putting x to the second negative 3, so x to the second minus 3. Then right here, x times x, and then negative 8i times positive 8i. So it's x to the second, and that would be negative 64i to the second. Okay, so we know we got x to the second. Now that's a negative 1, so it's negative 64 times negative 1, which is 64. And it's positive 64, so it's x squared plus 64. Okay. So yeah, the i's always turn into a plus. The radicals are going to remain a minus. Okay, find all roots of the equation by factoring. Okay, here's my factoring rules. 2 terms GCF dots, 3 terms GCF in the table, AC table. 4 terms I apply grouping. Here I'll write grouping. And then at the end of each one, we have to see all types need a dots check at the end. Now, I didn't say just factor it. You find the roots by factoring. See, x to the third means there's 3 roots we have to come up with. Okay. All right, now we have that x to the third, and we have that x to the second, and we have an x. There's no constant. 0 doesn't count, so that's 3 terms. So 1, 2, 3. So it'd be GCF table. Okay, GCF, you got an x at the end, you bet. You have a negative in front? No, you don't. 1, 7, 18 is 1. But it's 1x, so we need to list that over here as a factor. So I go up and do it. 1x, 1x, 1x. So 1 divided by 1 is 1. Now 3 minus a 1 is x to the second, and that's going to be minus 7x, and that's going to be minus 18 constant. You can ditch that because we've already placed it. Now ABC, AC product, 1 times negative 18 is negative 18. So it's a positive multiplied by a negative. And we're adding to try to get to negative 7. 118 doesn't do it. Divide by 18 by 2, you get 9. Aha, that's negative 7. Okay. I'm always going to be making 4 parentheses. So, I mean, if you don't think you need to do, that's fine. Okay, might help some of you. Okay, so A is 1x to the second. Now remember how I handle this. I know I've got plus 2 minus 9. Now these first terms, you keep the lead coefficient, you split the power, unless of course the lead coefficient's 1, you don't need it. Okay, but if that was a 4, I'd be placing a 4 and a 4, and then you have to split the x power into an x and an x. Now, had that been a 4, I'd go 4x, 4x, and try to divide down. But you know what? It's not. These cannot be reduced, so I bring them over here for the dots check. Well, the plus never can. Got a minus, but the x does not have a power, so that cannot happen either. So that's prime as well. And each one of these x's are to the first power, so there's one solution coming from each. Okay, so 1x could equal 0. Just divide by 1, you get 0. X plus 2 equals 0. You take 2 away, you get negative 2. X minus 9, you add the 9, and you get 9. So those are your 3 roots. Okay, number 8, x to the 4th power minus 10x to the 2nd power plus 9 equals 0. I actually want to change something here. Okay, I want to change this problem. I just got to think here. I would like you to make that a minus 9, please, and I want you to make that a plus 8, please. Okay. So rewrite the problem. X to the 4th plus 8x to the 2nd minus 9 equals 0. Okay. All right, so we have 4 roots. Okay, now we do have the x to the 4th. I don't have x to the 3rd. I got x to the 2nd, and I got the constant. So anytime I have the x to different powers like it is, I have to factor. Okay, it says factor in the directions. So 3 terms. So it would be GCF and t, just like the last one was. And then I have to do a dots check over here. Okay, so do we have the x on that one? Nope. You got a negative? No. So it's really just 1. So I don't need to put 1 there. Okay, that's worthless. Okay, so ABC from here. 1 times negative 9 is negative 9. So it's a positive times a negative. And I have to add the factors so I can get to positive 8. 1 and 9, that's negative 8. To make it positive 8, we just need a plus 9 and the 1 to be negative. Now, your A is 1x to the 4th. So, make those 4, and then minus 1 plus 9. Okay. Now, A is 1. Okay. If A is 1, you can ditch it, but you got to split the power into an x second, x second. Okay, now those can't reduce. Now bring them over here. X to the 2nd power minus 1, x to the 2nd power plus 9. Okay, the plus is dropped. Even if that's perfect squares, which it is, I can't factor it. Now the minus, you got xx and 1, 1. Okay. xx, 1, 1. Okay, and that's plus. And the other one's a minus, but we don't have an x to a power, so that's done as well. Now remember, we need 4 roots. Well, that x is to the 2nd, so we will get 2 roots from there, and we will get 1 root from each of these. So let's do the 2 first. Minus 9, minus 9. Got to poke the eye out, okay? Now, 9's a perfect square, okay? I would prefer you not leave that as a square root of 9 when the square root of 9 is 3, okay? So x could be positive or negative 3i. So 3i and then negative 3i. Or you can put i3, negative i3. I don't care. X plus 1 equals 0. One answer from here, that'd be negative 1. X minus 1 equals 0. That would be positive 1. Okay. We're going to come back to that problem here on number 10. Okay, number 9, x to the 3rd power minus 7x to the 2nd power minus 9x plus 63 equals 0. So there would be 3 roots. Well, you got an x to the third, got an x to the second, you got an x, and you got a constant. So that makes 4 terms. And now you got x to all these different powers, so you have to factor. Okay. So now it's 4 terms. 4 terms is grouping. Okay. So grouping. So parentheses plus parentheses, line parentheses plus line parentheses. Then little parentheses, big parentheses. Okay, so we have 1x to the third minus 7x to the second. Then we have negative 9x plus 63. Remember what these lines represent. They're the GCF from each of the binomials. Bi means there's 2. So you do your variable check. You have x to the second. Do your negative check. Okay. 1 and 7 is 1. Variable check. Negative check. 9 and 63 is 9. Okay. So you go up and divide these by 1x to the second, and you divide these by negative 9. So it'd be 1x, because x to the first, minus 7. And guess what happens here? Same thing. Okay. Okay, so 1x minus 7 is factored out. And then I combine the GCFs into a binomial. So 1x to the second minus 9. Now you got to do the dots check here. Okay, now we have minuses in both of them, but this one, take the 1s off. You don't need those there. That's not a difference of perfect squares. Okay, so that's done. This one is, you got minus, and you got x times x, and you got 3 times 3. So he's going down into 2. So x3, x3. Plus is dropped. The minus, not perfect squares, so x minus 3. Okay, all of these, the x's to the first power, so they all have just one answer, which will make 3. Okay. So plus 7, I get 7. Minus 3, you get negative 3. Plus 3, you get positive 3. Okay, now number 10 is a different problem, but it's not hard, okay? Refer to your solutions for problem number 8. Take the graph y equals x to the fourth minus 10x second plus 9. You don't have to make this graph. Don't make it. Now, anything higher than a second power does a roller coaster, okay? Leading coefficients would be 1, okay? So it'd be going up that way, and then it rolls around and all that. That way, okay? Okay, now, the roots. Go back to problem number 8. The roots are the answers you got for problem number 8, okay? 3i, negative 3i, negative 1, positive 1. Now the X-intercepts are the same as the roots. It's like a subcategory. They just don't include the i's. So negative 1 and 1, because a graph doesn't have i's on it. Okay, so that's where our graph would cross the x-axis. Okay, so I mean if you look at the x-axis, it would cross it here. That'd be 1. Cross it here would be negative 1. So it'd cross it twice. Now the y-intercept, where does it cross the y? The y-intercept's super easy to find. You just basically take your x terms out, because at the y-intercept, the x is at 0, okay? So if I take the x terms out, it's 9. The y-intercept's always the constant, okay? Not a hard problem. Okay, find the quotient. You are not redirections. You're not trying to solve for x. You're just dividing and writing your answer properly, and you're done. So divide. So 4, 23, negative 16. So x plus 5, you set that equal to 0 to find your dividend, and it's negative 5. Okay. So I carry down the 4. 4 times negative 5 is negative 20. 23 plus negative 20 is 3. 3 times negative 5 is negative 15. And that adds to negative 31. Okay. Okay, so the 4 goes from an x second to an x plus 3. And then you put your remainder of negative 31 over the divisor, x plus 5. Okay. That's your quotient. Okay. Obviously, you can't solve it. You got a remainder. Okay, number 12, x to the third power plus 21x to the second power minus 1x minus 24 divided by the expression x minus 2. Okay. So here's my dividend, 121. You got to put 1's in front of your x's so you know it goes there. There's your dividend. Now your divisor, you set that equal to 0, so you would be dividing by the 2. Okay. By the way, when you get a remainder, that means negative 5 is not a solution, a root of that polynomial. Okay. 23 times 2 is 46. 45. 45 times 2 is 90. And we get our nice remainder of 66. So now the one that was an x third, well now it's in 1x second. Plus 23x plus constant 45 plus our remainder of 66. You got to place that over the x minus 2, whatever the expression you're dividing by. So that tells me 2 is not a fact. 2 is not a solution if that was equal to 0. Okay, now the monster one. This will be the longest one. Use the rational roots theorem to solve the equation. We have x to the third plus 6x to the second, that is a plus, minus 1x minus 30 equals 0. Rational roots theorem. That means don't waste time trying to group. Okay, it's not going to work. So you're going to put RRT, okay, draw your ratio line, then you're going to make your L up there, okay. Now, there are 3 roots. I know I can find my last 2 using factoring methods like the GCFT, and if the T doesn't work, the quadratic formula, but this one, I'm doing the RRT. Okay, so I take the 30, the constant at the end, the leading coefficient's 1, so factors of 30 be 130, 2 and 15, 3 and 10, 30 divided by 4 is a decimal, 30 divided by 5 is 6, and then you're at 6. 1's 1. Okay, now if you divide all those by 1, they're really just 1, 30, 2, 15, 3, 10, 5, and 6. If you don't want to write them all out, that's fine. All plus negative. All could be positive or negative. Now these aren't the answers, they're the possibilities. Now I start plugging my way. Okay. And you have to find all the answers. Okay, you can't just find the first one and say yay. Okay, 1 didn't work, no sweat. 2 is a possibility. Zero. Okay, so I got 2 with the RRT. Now I get it down to an x second by dividing by 2. So 1, 6, negative 1, negative 30. Okay, so 1 times 2 is 2. 8 times 2 is 16. 15 times 2 is 30. And I got a remainder of 0. Okay. So now the 1 that used to be x third, I would line it up here. It's now 1x to the second plus 8x plus 15 equals 0. Okay. Now, pretend you're solving it, okay? Pretend you're just an x second, you got x second, you got x, you got the constant. That's 3 terms, okay? So it'd be GCF and table. Now somebody might ask, they're like, what if it was only 2 terms? Well, then you do GCF dots, okay? So GCF would just be 1, okay? So, because no x, no negative. Okay, 1 times 15 is 15, it'd be positive. Now, so the signs would match, but since it has to add to positive 8, we probably better match them up as positives. 3, 5, okay. Okay, now what's the A? A is 1x second. So if my coefficient's a 1, so I can drop that, but I do have to split that into x. So x plus 3, x plus 5, because if you FOIL that, you're back up this one. Okay? And if you made a second group, you would not be able to reduce. Okay? So x plus 3, x plus 5. Neither one of those is adopts, so we bring them down. Equals 0. Okay? X plus 3 is 0. So negative 3. X plus 5 equals 0. And negative 5. Okay? So again, you find the first answer with the rational roots. Let's do your synthetic division L. Takes it to an x squared, x constant, okay, where I know how to solve those. Okay, simplify the expression. We have 2x to the 3rd power, and then a second power outside the parentheses, and then a 5x to the 4th power, and a second power. So the operation within the expression is all multiplication. That doesn't mean all I do is multiply, but it means I can apply these properties. Okay, so we have 2 times x times 5, and then another x means I'll add to the power. Okay, so we got 2 to the first. 1 times 2 is 2. You got 2 factors of x, so 3 times 2 is 6, and then the other one, 4 times 2 is 8. Remember, in parentheses, you got to distribute the outside to the inside. So that's 14. Now the 5 is to the first. 1 times 2 is 2. All these exponents are positive, so they keep their same position. Okay, now this and this get simplified. That's a 4, that's a 25. So you would be smart to write 4 times 25 and then write your variable, because then you will see you could multiply 4 and 25. That's 100 times x to the 14th power. The bottom can be empty. Okay, if the top's empty, you got to put a 1. Number 15, we have 2x to the 3rd power, y to the 7th power, and then a parentheses, and then a negative second outside. So we have 2 times x times y. Okay, so a 2, okay. So 1 times negative 2 is negative 2. 3 times negative 2 is negative 6. 7 times negative 2 is negative 14. So all these are negatives. They all have to move to the bottom. They all have to, they move to the bottom because they're changing positions. If you have a negative on bottom, it switches to the top. And that one, that's 4. So on the bottom now we have 4 times x to the 6 times y to the 14th. Now if the top's empty, you cover it with a 1. Okay, you need a numerator to go with your denominator. Okay, number 16, 12x to the 5th power, y to the 3rd power, divided by 4x to the 3rd. So it's all division, multiplication. Okay, so I can apply my properties of exponents. So in the numerator, I got 12 times x times y. In the denominator, I have 4 times x. No, you can't add the x exponents because they're dividing. So 12's to the 1, 4's to the 1. No distributing on this problem because there's no parentheses. And a 5 and a 3. Then y to the 3rd. Okay, so when we have factors on bottom, we need to try to cancel. You have a 4 on top? No. You have an X? Oh, yeah. So one of these X's is going bye-bye. It's the one with the smaller power. Minus 3. 4 minus 3 is 2. Now these exponents are positive, so everything stays in the exact position it's in. Okay? And that's going to be a 12, and that's going to be a 4. Because that's 4, that's 12. X second, Y to the third. Now, this is something I haven't talked about, so I probably wouldn't dock somebody if they didn't do it. But if I have a 12 and a 4, you know, you would actually find what the GCF is of 12 and 4. It's 4, and you divide them by 4. So that would be a 3, that would be a 1. If you have a 1 on the bottom, you really don't need it, okay? So it'd be 3 times x to the second times y to the third. You can put it over 1, but you don't really need a 1 on the bottom. You need it on top, but not on bottom. Okay, we're going to skip the next two. Those you will not be required. You will not be held accountable for those applications. Okay. A company's profit can be modeled by the equation C equals negative 5x to the third power plus 6x to the second power plus 15x, where x is a number of items produced in thousands. The profit is $14,000 for producing 2,000 items. What other numbers of items would produce the same profit? So I write out the equation I'm given. Don't write it overly large. That's a negative in front of your 5. Now we got to know what the variables mean. Okay. C is cost, X is items, and they just say items, so yeah. Okay, now they give me values for those at the same time in the same sentence. So 14,000, 14 is C, 2 is X. Now we're going to verify that that's true. So 14 goes in for C, 2 goes in for X. Now plug that into your calculator and verify that you get 14. I did. I got 14. Good. So that's true. Now we turn those back into x's, and I find the rest of the roots that would give me a cost of 14. So there's 3 roots. And guess what, Sparky? You already know one of them. You know one of them's 2. Okay. So I'm going to minus 14, move everything to one side, and I'm going to synthetically divide. I'm not going to waste time trying to group them. So I got a 2, and then I'll be divide from there, and I got a negative 5, a 6, a 15, and a negative 14. You got to remember to move the 14 over. Negative 5 times 2 is negative 10. Negative 4 times 2 is negative 8. 7 times 2 is 14, and that's 0. Okay. There's your remainder. Now you got your new equation. Negative 5x squared minus 4x plus 7 equals 0. I usually like to write it over here. That's just me. Okay, so we got to find these two answers now. We got x to the second, and we've also got x to the first, so we need to think of a form of factoring. It's 3 terms, so it would be GCF and the chart. Positive, x there? No. Negative there? Yeah. 5, 4, and 7 is just a 1, okay? So it's a negative 1. I'll put it down here. Not that I really use it to solve because it doesn't have x, but I'll put it, okay? Then I divide everything by negative 1. So it's going to be 5x squared plus 4x minus 7. Then I hit a problem. 5 times negative 7 is negative 35. So it's a positive times a negative. 135. And the only other thing you really have is 5 and 7. Because you're trying to add this to get plus 4. It doesn't work. Okay? So that's QF, quadratic formula. That's a prime expression. You can't put it into parentheses. So opposite of b, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a, over to, well, we know a is 5, so it's going to be 10, okay? Now in the square root, we got a 4, a is 5, c is negative 7. So we have negative 4, we have 10. Now let's evaluate the square root into the calculator, just so I don't make any little careless mistakes. So 4 to the second minus 4, 5, negative 7. Okay, 12.49. And I get my other 2's. So negative 4 plus 12.49 divided by 10. I got 0.85. That's okay, that's 850. Then I take negative 4 minus 12.49 divided by 10, and I got negative 1.65. Alright, so we could probably get rid of the negative. That's not a viable solution to a story problem. And then the x is items, but they're in thousands, so I put k, items, items.